This number 23, we are simplifying the angle between VC and the base of the pyramid. So ABCD is the rectangular base, which has a diagonal from A to C. So because this is 10, this is 12, we're given there, we can actually find the diagonal length by Pythagoras theorem, which is AC square root of 12 squared plus 10 squared. It will give us a square root of 244, which simplifies to 15,62. And MC is half of 15,62, which gives us 7,81 centimeters. That is MC from here to there. So if I can take this part and redraw it here, I will have C here, M there, and V. Then this is a right angle triangle. We are given 14 and 7,81 for the dimensions. So we want to find the angle there. So we know that SOHCAHTOA is used to simplify triangles. This one is my hypotenuse, this one is my opposite, this is the adjacent side. So I have the hypotenuse and the adjacent, meaning I will need to use cosine ratio. So cos theta is equal to adjacent over hypotenuse, and adjacent is 7,81, the hypotenuse is 14, meaning for me to find theta I'll have to find the cos inverse or arc cos of 7,81 divided by 14. I'll punch this on a calculator and get the answer. Arc cos of 7.81 over 14, 56.02. Right, so this is 56.1 degrees. There you go. There's number 24. Let's do number 24. So this is the final question, and we'll do it real quick. So this one is an equation, y equals to x cubed minus 2x squared plus 5, and we want to find the stationary points or the turning points of this graph. So for us to find the turning points or the stationary points, we need to differentiate or find dy dx, which is found by saying 3, you take 3 down there, you put your x, and then you subtract 1 from this power, so you get 2. Minus this 2, you bring it down, it multiplies that 2, you get a 4. The power is reduced by 1, so 2 minus 1, it becomes 1. So basically this is just as good as 3x squared plus 4x. Right, at the stationary points, we know that dy dx must be 0 at the stationary points. So because dy dx equals to 0, we can simply equate this 3x squared plus 4x to 0, and we go ahead and calculate So this is a factorization kind of a question. So you can say x outside the bracket 3x plus 4 equals to 0 because there's x here, there's x there. So x equals to 0 or 3x plus 4 equals to 0. I think this one is not very difficult to understand. This equals to 0 or this equals to 0. So 3x equals to minus 4. Oh, this is now a positive 4 since this was a negative 4. Negative 4, negative 4. So this is 3x equals to 4, then x equals to 4 over 3. Now we've got x equals to 0 and x equals to 4 over 3. To find the coordinates of the stationary points, we need to substitute into this original equation this value of x, which is 0, and this value of x, which is 4 over 3. So when x equals to 0, y equals to 0 cubed minus 2 times 0 squared plus 5. So all this is 0 minus 0 plus 5. So y is 5. So the first coordinate will be 0 for x, 5 for y. And we are going to put it in this space for the answer. And we'll do the same thing for y. So let's do this. So x is 4 over 3. Y equals to 4 over 3 cubed minus 2 times 4 over 3 squared plus 5. And let's use our calculator to do this. 4 over 3 is equals to 1.333. So we'll keep this as our answer, then we punch. So the equation is there. X cubed minus 2x squared plus 5. So I'm going to say this answer cubed minus 2x cubed, this answer squared plus 5. What am I getting? I'm getting 103 over 27. So I'm going to write 103 over 27 so that my second coordinate is 4 over 3 and 103 over 27.